Hello viewers, today our topic is going to be polygons. So in this class we explore the properties of polygons. We start with triangle, then we'll go for quadrilateral, then we'll go for pentagon, then after hexagon. We are going to look at what are sum of interior angles and what are interior angles, what are sides and what are number of diagonals, what are number of triangles in it, and what are exterior angles of these polygons. So first we start with three-sided polygon, that is triangle. So let's take a triangle. This is polygon with three sides. Then we'll go for a quadrilateral, that is a four-sided polygon. Then a pentagon. Then after a hexagon. In the previous class we have seen about triangles, and we know sum of angles in a triangle is 180. Sum of angles in a triangle is 180. Number of sides of the quadrilateral is 4. Number of sides for pentagon is 5. Number of sides here is 6. Now look at what is sum of interior angles of a quadrilateral. For a quadrilateral, from one vertex you divide the quadrilateral into two triangles, and two triangles are non-overlapping. So I am dividing it into 1, 2. Now if you observe carefully, the sum of angles of these interior angles of this triangle is going to be sum of interior angles of this quadrilateral. Therefore, there are two triangles, each triangle sum of interior angle is 180, therefore 2 into 180 is equals to 360. Then after we will go for a pentagon. From one vertex you join all the vertices. I am dividing the pentagon into three non-overlapping triangles. Look at here, triangle 1, triangle 2, triangle 3. I am dividing the entire pentagon into three non-overlapping triangles. These non-overlapping triangles, if you look at, the sum of one triangle is 180, therefore 2 and 3. So 3 into 180. Sum of interior angles of a pentagon is 540. In the same manner, you take hexagon also. From one vertex, you join all the vertices. Take it only from one vertex, because I want the triangles to be non-overlapping. Because the sum of interior angles of these four triangles, if you do the sum of all these angles, you should get the interior angle of hexagon. See, that's how we got. So how many triangles we see? 1, 2, 3, 4. Therefore, sum of interior angles of a hexagon is equals to 4 into 180. 4 into 180 is equals to 720. Now it follows a logical order. First, if you look at the number of triangles is equals to 3, number of sides in a triangle is 3, sum of angles is equals to 180. Now n is equals to 4, number of sides are 4, then it is 2 into 180. For a pentagon, number of sides are 5, it is 3 into 180. For a hexagon it is 4, it is for hexagon it is 6 sides and it is 4 into 180. So if you follow the logical order, for a 6-sided figure you can divide it into 4 non-overlapping triangles. In the same manner, if you follow for a 10-sided figure, for a decagon, you can divide the decagon into 8 non-overlapping triangles. Every time it decreases by 2 in number. So for an n-sided polygon, if you look at, for an n-sided polygon, the number of non-overlapping triangles that you can draw in that polygon is n minus 2. Therefore, sum of interior angles of a n-sided polygon is equals to n minus 2 into 180. If it is a regular polygon, what do you mean by the term regular? Regular means all sides and all angles are equal. For a regular polygon, each angle, so here I mean to say each angle of n-sided regular polygon is n minus 2 into 180. You have to divide it into n parts. Therefore, each angle will be divided by n. Suppose for a triangle, Regular triangle means equilateral triangle. Regular quadrilateral means square. Equilateral triangle, we know that each angle is 60 degrees because the total angle is 180. We divide the total angle by how much? We divide the total angle by 3. Therefore, if it is an equilateral triangle means regular triangle. All the angles and all the sides are equal. Suppose if it is a square. For a square, each angle becomes 90. How do I get 90? Because 360 is the total angle. You divide it by 4 so that you get 90 degrees over there. So as the case in case of pentagon, 540, if it is a regular pentagon, so all sides and all angles are equal. 540 divided by 5, you get 108. So same is the case with n-sided polygon. Each angle is n minus 2 into 180 divided by n. So in the similar manner, now we go for the exterior angles. Let's take a triangle. I am drawing the exterior angles. I am extending these lines. Take quadrilateral also. I am extending them in one direction. Pentagon also. All these angles that you see here are exterior angles. So these are all our exterior angles of polygons. Now this is an exterior angle of pentagon. If you look at the exterior angle of a triangle or a quadrilateral or a pentagon, you see them closely, you observe that these angles forms a circle. Okay. If you look at it carefully, it is like one complete revolution. So one complete revolution is nothing but one complete circle. If you cut this angle and if you join them, you will get a circle. So what is angle in a circle is 360. Therefore, what is sum of exterior angles? Sum of exterior angles is simply 360 degrees. Now assume that each quadrilateral is each polygon is a regular polygon. If each polygon is a regular polygon, what is each exterior angle? Each exterior angle is 360 degrees divided by n. Now one more thing we can clearly see here. This one is an exterior angle and this one is an interior angle. Here you see this is interior and exterior. In any polygon you take, interior angle plus exterior angle should always be is equals to 180 because it forms a linear pair. So interior angle plus exterior angle is equals to 180 in n-sided polygon. So here number of sides doesn't matter. It is independent of number of sides because it is always forms a circle. It is 360. Each exterior angle of n-sided, it must be regular, otherwise you can't find out. Regular polygon is equals to 360 degrees divided by n. And one more thing we know is each interior plus each exterior is always 180. It forms a linear pair. Remember that. Now, what kind of question they may ask you? I am just giving you an example question. Which of the following is interior angle of regular polygon? It can be a multiple answer question. Let's say option 1 is 170, option 2 165, option 3 160, option 4 155, 150, 145, 140. Which of the following is interior angle of a regular polygon? First of all, we need to check, is 170 is an interior angle of a polygon or not? If interior angle is 170, then exterior angle must be what? 10. Number of sides is equals to, you can say 360 divided by exterior angle, and vice versa. If you want exterior angle, it is 360 divided by n, and if you want number of sides, it is 360 by exterior angle. So number of sides, is it an integer or not? You have to check. Yes, it is 36, therefore it is accepted. If I take 165, it becomes 15. 360 by 15, it is an integer value. Yes, you can accept. 160, 20. Yes, you can accept. 155, which means 25. 360 is not divisible by 25. You cannot accept this. 150, so it is 30. You can accept it. 145, it is 35. You cannot accept because 360 is not divisible by 35. 140 means it is 40. We can accept it. So what are not each interior angles of polygon? I can say it is 155 is not interior angle, 155 is not an interior angle because exterior angles cannot be 25 and 35. That is the reason these are not interior angles. So don't check with n minus 2 into 180 divided by n, it will take more time. Now we'll look at diagonal. First of all, what do you mean by a diagonal? For any polygon, diagonal is a line which divides or which joins the opposite vertices of a polygon. So diagonal is a line which joins the opposite vertices of a polygon. Now if you look at triangle will not have any diagonal because every vertex is the adjacent to the other. There is no opposite vertex in case of triangle. So number of diagonals in case of triangle is 0. Now go for a quadrilateral, or else a pentagon, or else a hexagon. Now look at number of diagonals in it. Number of diagonal in case of a square, join opposite vertices, there are 2. In case of a pentagon, 1, 2, 3, 4, 5. So there are 5 vertices, 5 diagonals. In case of a hexagon, 1, 2, 3, 4, 5, 6, 7, 8, 9. But in the exam, so if they give you number of diagonals in a hexagon or septagon or octagon, first of all, drawing an octagon in the exam is difficult thing. And okay, imagine drawing diagonals in it. So you cannot draw diagonals in the given time. So we need to find out a way in order to find out the number of diagonals in it. So first, let me take 5 points. Just take 5 points. 1, 2, 3, 4, 5 points. Name them 1, 2, 3, 4, 5. By using 5 points, number of lines formed. Number of lines formed. How many lines we can form by using these 5 points? 5C2. You just need to select 2 points out of 5 points because a line needs 2 points. 5C2 is 5 into 4 divided by 2, which is equals to 10 lines. And what are those 10 lines? You can say 1, 2, you can say 1, 3, 1, 2, 1, 3, 1, 4, 1, 5. Write it in ascending order. 2, 4, 2, 3, 2, 3, 2, 4, 2, 5, 3, 4, 3, 5. Then after 4, 5. We know that there are 10 lines, just now we have seen. So what are these 10 lines? See here. The 10 lines formed are name it. You see lines in blue color are actually sides of a pentagon. The lines in red color are what? The diagonals. So out of this take out blue color ones. 1, 2, 2, 3, 3, 4, 4, 5, 1, 5. These are sides. So number of lines minus number of sides. It is a 5-sided figure, so you subtract 5. Therefore, you get what? 5. 5 diagonals for a pentagon. So for any polygon also, you just find out the number of lines formed by the given vertices. You subtract the number of sides. So that in that way you will get the number of diagonals easily. So for n-sided polygon, number of sides or else number of lines formed is equals to NC2 and number of sides. It's an n-sided polygon, therefore number of sides or vertices will be n. Now we will get number of diagonals. Now number of diagonals is equals to NC2 minus n into n minus 1 by 2 minus n. If you simplify it, it will be n into n minus 3 by 2. So number of diagonals formula is n into n minus 3 by 2. Now if I wish to find out the number of triangles formed in this particular figure, I am just asking you the number of triangles in a pentagon which are formed by using the vertices of pentagon. How many triangles are formed by using the vertices of pentagon? 1, 2, 3, 4, 5. In order to identify, I am giving you the vertices and I am asking you the number of triangles formed by using the vertices of a pentagon. Now see here, I would say this is a triangle, but I cannot accept this as a triangle because it is not formed by using the vertices of a pentagon. So this is not a triangle, this is not a triangle. These are all not the triangles I am looking for. Now look at what are the triangles actually I am looking for. See the triangles I am looking for. I am looking for the triangles which are formed by vertices of a pentagon. See this triangle 1, 3, 4. It's formed by using the vertices of a pentagon. In the same manner, look at this. This is a triangle which is formed by using the vertices of a pentagon. Now look at 3, 4, 5. This is also a triangle which is formed by using the vertices of a pentagon. Now in order to form a triangle, what all you need? All you need is just 3 points. So what you have to do is simply select 3 points out of 5 points. So selection of 3 points out of 5 points is simply 5C3. How many triangles are there in this figure which are formed by vertices? 5 into 4 into 3 by 3 factorial is 6. There are 10 triangles. Generally for n-sided polygon, it is NC3. NC3 formula is n into n minus 1 into n minus 2 divided by 6. So we have seen sum of interior angles, sum of exterior angles, each interior angle, each exterior angles, number of diagonals and number of triangles formed by vertices of a polygon. You can also find out the number of rectangles, number of quadrilaterals, number of pentagons in n-sided polygons. If I ask you the number of quadrilateral formed by using the vertices of an n-sided polygon, for a quadrilateral you need 4 points, so say NC4. If you want number of pentagons in an n-sided polygon, it is simply NC5. It goes on like that. Now we'll look at the problems based on this. Look at the first sum. The first sum says if the angle of a regular polygon is 162, then the number of sides of a polygon is. We have a formula for interior angle. When they say angle, you have to take an interior angle or internal angle. So interior angle of a regular polygon is 162. So don't take interior, take exterior angle. I would say exterior angle is 180 minus 162, that is 18. How do we find out the number of sides when exterior angle is given? You just divide 360 by exterior angle 18. So number of sides is equals to 20. So in this way you can easily find out the answer. Now see here. Second one. There are n corners in a closed figure. If the sum of internal angles is 13 pi, it is given in radians, then the value of n will be, so in radians each interior angle, in place of 180 you just put pi, so n minus 2 into, instead of taking 180 you take it as pi, because you just divide it by pi by 180, so it convert into radians. 13 pi, pi gets cancelled, n minus 2 is equals to 13, therefore number of sides of a polygon is 15 sides. Third one. If one interior angle of a regular polygon is greater than one of its exterior angle by 144, sum of interior plus exterior angle, we know that it is 180. Interior is greater than exterior by 144. So how many sides of the polygon? In order to find out the sides of the polygon, don't find interior, find out the exterior angle, cancel it. So 2 into exterior is equals to 36, exterior angle is 18, therefore number of sides is equals to 360 divided by 18, which is equals to 20 sides. There are two regular polygons with number of sides equal to n minus 1 and n plus 2. Their exterior angles differ by 6. What are exterior angles when number of sides are given? 360 divided by n minus 1 minus 360, because they differ by n plus 2. The difference between their external angles is 6. Divide everything by 6, you get common 360 divided by 6, it will become 60. N plus 2 minus n minus n plus 2 minus n plus 1 divided by n minus 1 into n plus 2 is equals to 1. So all you left will be, see here, n minus 1 into n plus 2 should be is equals to 3 into 60, 180. Look at the value of n from the options. If n is equals to 14, we know 13 into 16 will not be 180. This is not the answer. Option B, 11 into 14 is not 180, 13. 12 into 15 is 180. So the answer is n value is 13. So rather than solving the quadratic equation, just substitute it from the options so that you will get it quickly. If the interior angles of a 5-sided polygon are in the ratio 2:3:5:5, then the measure of the smallest angle is 2. 5-sided polygon, sum is equals to, as we know, 3 into 180. Assume the angles as 2x, 3x, 3x, 5x and 5x. Put together, 18x is equals to 3 into 180, x is equals to 30. If x is equals to 30, the smallest angle is 2x, which is equals to 60 degrees. Look at the next sum. Find the number of diagonals that can be drawn by joining the angular points of a polygon with 100 sides. We know the formula for number of diagonals, that is n into n minus 3 divided by 2. 100 into 100 minus 3 is 97 divided by 2. So 9700 divided by 2 is 4850. So, these are some sums and the basics of polygons. Thank you everyone.